Hi, you're welcome to our day 3 of the machine learning project. Now, if you're watching from my YouTube channel, you're welcome also. So, join us on the topic today, feature engineering for power data. Now, remember, we are trying to use the energy data we've gotten from UCI, which can also be found in Kaggle. Now, this is a comprehensive guide to analyze household power consumption. Now, let's proceed with what we have for today. Now, our overview. Now, this section, we're going to introduce a practical guide for feature engineering using the household power consumption data set. Also, we are going to explore on how to transform raw data into meaningful inputs for machine learning models using time series and statistical features. Now, first of all, let me introduce what is feature engineering. Maybe you're curious about it. Now, feature engineering is just a presentation that explores the importance and techniques of features engineering tailored for household power data. Now, it provides insight on maximizing predictive performance through effective data manipulation. Now, another thing you need to understand will be the data libraries. Now, first of all, it's very important for you to note that data libraries like pandas allow us to handle, manipulate, and analyze structured data easily. And I believe I mentioned this in our day 1. So please make reference to that in the video, in the playlist titled Machine Learning Project. That is the first lecture in the playlist. Now, also, let's proceed. The data libraries provide high-level data structure such as data frame, which act like Excel tables but with coding power. Now, why are they important? First, they allow us to do data cleaning, transformation, and extraction with precision and scalability, and also is essential for working with large data sets, such as energy usage log collected every minute or hour. Now, how do we load the data set? First, you need to understand what is data set. Why do we need data set? So let's proceed with what. Now, data set is a structured collection of data, in this case, power consumption logs. Now, it typically includes fields like voltage, power, submeters readings over time. Now, we proceed with why parse data time. Now, passing the datetime column converts plain strings into time-aware objects. Now, this enables powerful time-based analysis, such as grouping by hour, day, or month. Now, we need to identify the key numeric features. What are numeric features? Now, first, there are quantitative features such as active and reactive power, voltage and current intensity, energy readings from different appliances. Now, the next thing you need to know is why are we selecting them? Now, feature engineering starts by choosing the important numerical attributes, also considered as characteristics or variables that contribute to prediction or classification tasks. Now, we need to ensure data type compatibility. Now, this helps us to understand the importance of these features. Why convert data types? Now, that is the first thing we need to ask ourselves. Raw data may contain string representations of number or mixed types. So machine learning model require us to be consistent in our data types. So typically floats for numerical features to perform mathematical operation. Now, what is the impact? One of it is it prevents runtime errors and ensure models can calculate relationship accurately. Now, another thing we'll move on with is extracting hour of the day. Now, why extract hour information? Now, power usage often follows a daily pattern, high in the morning and evening, lower at night. Now, by extracting the hour, we can model this behavior. Now, example use case, a spike at 6 p.m. may indicate cooking or heating, useful for predictive energy demands model. Now we move on to talk about purpose of weekend features. Now, human behaviors varies by weekday, e.g. weekday versus weekend. Businesses and homes often shows different power usage on Monday versus Sunday. Now, applications. This helps us to distinguish work week pattern from weekend relaxation routines. Now, scaling and normalization, which we also call standardization. Why do we need to scale our features, or also known as characteristics or variables? Now, our machine learning models are very sensitive to the range of input data provided. So, for example, kilowatts and volts are on very different scale. So it is very important for us to scale this. So two common techniques we can use for our scaling will be standardization. What standardization does is that it centers the data between 0 to 1, where 0 is the mean and 1 is the standard deviation, also symbolized as STD. Now, min max, that is minimum maximum normalization. Now, this helps to scale values between 0 and 1. Now, when do we use these two common techniques? Now, StandardScaler is good for Gaussian distributed data, whereas MinMaxScaler is better for data that must remain bounded. Now, what does feature scaling do? Now, one thing feature scaling does is it transforms raw numeric values into a consistent scale across all features. It prevents large magnitude features like voltage for dominating smaller ones like submetering _1, which we can see from the datasets which I presented in our data class. So please make sure you have access to the datasets we treated in day 2 from the playlist. Now, why 2 versions? Some model perform better with standard features other than with normalized data when experimenting. Well, experimenting with both is a good practice, so you could try out both. Now, deriving new features, apparent power. Now we are going to look at what is apparent power. Now, apparent power is just the combination of active and reactive power. So in electrical system, active power does real work, e.g. heating, whereas reactive power sustains the electric and the magnetic fields. So apparent power gives a holistic view of total energy capacity used. Now, what is the formula? So you can see the formula this way: a square of the active power of 2 plus the reactive power of 2. Now, another thing we should consider is the usefulness. Now, one thing is that it captures complex interaction in electrical usage and adds predictive power to energy forecasting models. Now, saving engineered features. So this part is very important, especially when you have carried out your feature engineering tasks. Now, it is very important for you to save. But let's see, why do we need to save the final data set? Now, after you're transforming, after processing your data set, your raw data set, it is very important for you to create a new version that is rich in feature and model ready. This tells us, at this point, I believe we have gotten the good quality data of good integrity. Now, once we are ready to use this kind of data set, it quickly tells us that our model is going to perform better than just using the raw data. Now, how do we save this version? We need to avoid redoing the same transformation and make sharing and deployment super easy. Now, file format. Now, we have the CSV, which info is called the comma separated values, which is commonly used for portability across tools and platform. So thank you so much for listening and watching. Now, if you're just joining this channel for the first time, Don't forget to subscribe. Also, remember to share, like, and to hit the notification bell so that you can get notified on my new videos. Thank you for watching. I'll be signing off now. Bye.